So if we're trying to solve this inequality, um, first just take a quick look at what it means to be less than 0, like this is saying. Okay. So if you have a graph like this, if the x part is less than 0, that means you're below the x-axis. So these areas I'm highlighting in blue would satisfy that condition. Okay, this is less than 0. This is all less than 0 because it dips below the x-axis. The y values are negative, in other words. Okay, so that's what we're really looking for. And another thing we can use is that it's a polynomial. That means polynomials have like a behavior that we can always identify. Okay, and it's a polynomial because if you multiplied it out, it'd be like x to the 4th plus like 3x squared plus, powers of x that are integers. No fraction powers, no square roots, or any weird stuff like that. Okay, so because we know it's a polynomial, we know it has to make some sort of shape like this. Okay. So what we can do is, since it's already factored for us, we can find out where the polynomial crosses the x-axis. We got x minus 8, x has one linear factor, x minus 2 is another linear factor, x plus 4 is a linear factor. This is all less than or equal to 0. So if x equals 8, if you plug in 8 right here, 8 minus 8 makes 0. 0 times all this stuff makes 0, and then 0 times all this stuff makes 0. So that means that x equals 8, the graph crosses the x-axis. We don't know if it's going like this or if it's going like this, but we can find that out in just a second. Okay. So if x equals 2, 2 minus 2 makes 0, and then it just starts that chain reaction where 0 distributes, makes everything else be 0. So we know it's also going to cross the x-axis here, and then you probably know this last one, negative 4, because negative 4 plus 4 makes 0. Okay, so now we got to figure out what it's doing. Is it going from down to up, or is it going from up to down? And what you can do to test that is you can plug in some test points. Like let's plug in x equals negative 5, a point that's slightly to the left of negative 4. Okay, so if you plug in negative 5 minus 8, plug it in for x, we got negative 5 minus 2, and you got negative 5 plus 4. Yeah. If you do that out with a calculator, well, you're simplifying a little bit more. This is negative 13. This is negative 7. That's negative 1. So negative 13 times negative 7 makes positive 91 times another one makes negative 91. So x equals negative 5. We're way down here. That means the polynomial has to be changing like this. Okay? Because, again, we plugged in negative 5. We got y equals negative 91. It's way down there in the x-axis. So let's plug in another test point. You can pick whatever you want, just so long it's between the, it's on some sort of interval. We want to know what's happening between negative 4 and 2, roughly. So an easy one to plug in usually is x equals 0. I don't think that'll help us that much, but if you plug in 0 for x, okay, that makes negative 8 times negative 2 times 4. So negative 8 times negative 2 makes 16, positive 16. Positive 16 times 4 makes 64. So that means at x equals 0, the graph is somewhere up at 64. So we know the polynomial has to have this type of shape. Okay? Because again, we said all polynomials look like either this, or they could look like this. They go from increasing to decreasing. They have these little peaks to them. So we know it crosses at negative 4, we know it crosses at 2, and we know it's positive in between them, so it's got to reach some sort of peak in between there. So let's pick another one. Now we want to find something between 2 and 8. So even numbers usually are easier to do in my head, so I'm going to pick x equals 4, but you could have picked x equals 3, x equals 5. If you plug 4 in here for x, 4 minus 8 makes negative 4. 4 minus 2 makes 2. 4 plus 4 makes 8. So we know the number is going to be negative, and that's pretty much all you really need to know. What the actual number is, it doesn't really matter, but 4 times 2 makes negative 8, because it was a negative 4 there, times 8 makes negative 64. So it's going to be somewhere way down here. So we know the graph dips like this. And then, just to make sure we covered all of our bases, let's try x equals 9, something slightly to the right of x equals 8. So 9 minus 8, 9 minus 2, 9 plus 4. So we got 1, 7, 13. Times 13 gives us 91. So at x equals 9, we know it's a pretty positive number, so it starts increasing from there. Okay, so final answer here. We were trying to identify where our polynomial, this one says less than 0. So from all the way back to negative infinity, because it's a polynomial, it can only cross at these 3 places, according to that what we had in the factored polynomial there. It means all the way back to negative infinity. You know, any negative number back here to negative 4. Here, I'm running out of room. Let me write it up here. From negative infinity, it goes least to greatest when you write these interval notations. So negative infinity is as small as we can go, and then negative 4 is the next place we have to stop. We're going to put a bracket because it says less than or equal to. So bracket on that negative 4. And then union, and we're going to pick up the interval. Oh, sorry. From negative 4 to 2, no good, right? Because it's above the x-axis. The next place where we can pick it up is at 2. So bracket because of the line underneath. From 2 to 8, it dips below the x-axis. So 2, 8 bracket and the other places. Okay, so use the Alex buttons. Hit this. You'll want to actually hit this button for the first interval. Okay. You'll use the negative infinity symbol, and then negative 4 goes in the empty box there. And then you use this union button to get the next interval. So this button, plug in your interval, then hit union, and then you want this button next because it's bracket 2, 8 bracket. Okay, let me see if I can do another one here for you. Now we have the general idea. I'll do this one a little bit quicker. This is a polynomial. This one's going to cross at negative 2, because if you plug in negative 2, makes 0. Negative 6 and 4. So we need to check everything to the left of negative 6, everything in between negative 6 and negative 2, everything between negative 2 and 4, and everything between 4 and positive infinity. We got to check all those intervals. So we check x equals negative 7, negative 7 plus 2, negative 7 minus 4, negative 7 plus 6. Okay, so you check those numbers. You're going to get negative 5 in the first parentheses times negative 11 in the second parentheses times a negative 1 in the third parentheses. So we get negative 5. That means it's down somewhere way down here. Okay, and it hits this negative 6, and then most of the time, yeah, if it's a polynomial, most of the time it usually goes up in between. But sometimes you see polynomials that stop like this. So we should, to be thorough, we should check it. Eventually you'll learn some other things with polynomials that let you be confident that it's not going to do that in this case. But to be thorough, let's plug in something in between negative 6 and negative 2, like x equals negative 4. So negative 4 plus 2 times negative 4 minus 4 times negative 4 plus 6. Okay, so when I calculate that first parenthesis is going to be a negative 2. The second parenthesis is going to be a negative 8. And then the third parenthesis is going to be a positive 2. So we get 32. So 32 somewhere up here. We know the interval is going to look like this. Now we got to make sure it dips below the x-axis. We know it probably will, but just to be safe, plug in x equals 0, a number between those two. Okay, we're done with that one. So we get 0 plus 2. 4, 0 plus 6, so that's 2 times negative 4 times 6. So we be at negative 48. So indeed it does dip below, goes down to negative 48, comes back up to 4, and then you want to check a number just slightly to the, it doesn't have to be slightly to the right, it could be really far to the right. Just check any number to the right of 4. Okay, so this gives us 7, 1, 11. That's going to be 77. That's a big positive number, so we know it goes up like this. Can't dip back down because it's a polynomial. It'd have to cross the x-axis again, which it doesn't, okay? Because it's x to the third power. But either way, yeah, that's what you want to do for these problems. Okay, oh, sorry, I didn't make the interval for this one. Final answer here. Where is this one greater than 0? So it doesn't have the line underneath. That means I'm going to be using lots of parentheses, because the parentheses means does not equal. And now they're asking for where it's greater than 0. So we want this interval and this interval. So it's greater than 0 between negative 6 and negative 2. Notice the parentheses, right? Because it can't exactly equal those endpoints. And I'm going to use that union button. And then it's from 4 to positive infinity. Because 4 is the starting point of this interval that I circled. Infinity is the last x place I can go. In other words, it never stops. Okay, so that would be your interval for this one.